Hello, this is the January Approachable Sudoku for the 31st of January. It is Dead or Alive Arrows by Bill Murphy. So you have two different types of arrows here, which were used by Clover in previous puzzles. So yeah, okay. We're gonna look at them right now. Normal Sudoku rules apply. Digits 1 to 9 must be placed in every row, every column, and every 3x3 box. Digits in cells containing white arrows, so these are white arrows. Whatever digits in there must appear in the given direction. So if this was an 8, for example, then somewhere where it's pointing must also contain an 8. Yeah, so basically these are your those are I guess those are the live arrows where they point at something else that is itself. Digits containing gray arrows, so these arrows here, cannot appear in the given direction. So those digits, for example, can never contain a 1 in them because a 1 is in a gray arrow here. Alright, and those are the rules. With that, let us begin solving. So we do have 9 and 1 here, which cannot appear in any of the cells it's pointing at. But I think more importantly would be these white cells, because they give us a lot more information. Those cells, for example, have to be 7, 8, and 9 to complete the box. And actually we can fill those in. Well, not fill those in, but we can almost fill those in. It gives us a chocolate teapot here. And similarly, 1, 2, and 3 must be here. Which we can place like that. And these arrows here must actually be pointing at whatever this digit is, right? Because whatever is here must be somewhere in this direction and can only therefore be this digit. This digit is therefore 1 or 3, but can't be 1 by the column, so that's 3, meaning that's 3, so we can fill everything in. This digit is also similar, because it must be 7 or 9, but it can't be a 9, so it's 7, meaning we can place those digits in order like that. Right, and so 7, 8, 9 pointing at those 3 cells mean that there must be a 7, 8, and 9 in those 3 cells. And we can do the same with 1, 2, and 3 over here. This cell, though, does point at a 2, which means we cannot have a 2 in here. And similarly, this can't be 8. But by Sudoku, it also can't be 7, so it's 9. This one also, it's also just a 1. Yeah. Alright, so what next? This digit maybe? Yeah, this digit points at one of those 2 cells, but can't be a 9 by the row, so it must be a 7, which resolves a 7, 8 pair. And then this digit must be a 1 or a 3, but can't be a 1, so it must be a 3, which resolves this 2, 3 pair. And I think by now I should be able to fill in most of the 3s. Yeah, 3 must be there and there to fill up all 9 of them. And I think we can do the same with the 7s. 7s are there, and there. Could do the same with 9s as well, maybe. Not really, no. Or maybe 8s? Nah, alright. Well, whatever it is, we can still look at these and say stuff, I think, about 5, 8, and 2. Because these arrows point to 5, 8, and 2, so they can never contain 5, 8, and 2. It doesn't give us much, because 2 is already there, so... And here I think it's a similar story. Alright. Or whatever it is. Let's see if we can do more Sudoku then. 2 is in one of those cells because of these 2's over here, which does push a 2 into this cell to in that box. 2's... No, 2's don't do anything else. Let's just finish this column, then 2, 4, and 9. This can't be 2, that can't be 9. Whoa. And here we have 3, 5, and 7. And this can't be 3 or 7, so that's 5. And then the 7 on the side resolves the remaining pair. And this is 1, 8, and 6. Which actually does give us something known as roping. So that's cool. You can see that those digits are all the same, which form like ropes here. Anyway, what now? Can we do more Sudoku? Maybe not. I mean, we have to do the Sudoku, right? can put an 8 there, which means 8 in this box must be there. So maybe it has to do with the arrows. Right, because where does 5 go? No, where does 2 go? No, 2 is in one of those cells. And then 5, because it can't be any of those arrows, must be in one of those cells. It can't be there either. So let's say 5 is in there. Then what? We still can't say much, I think. We might do the same here where 5 is in one of those cells. No, okay. Okay, 1 in this box must be in one of those cells, which does look at those cells here, which means 1 is in one of those cells. Maybe 9s? 9s are a similar story, I think. Yeah, 9's in one of those cells, which means 9 must be one of those cells. Oh, sorry, this 1 sees that, so 1 goes there, and I think 9, yeah, this 9 sees that, so 9 goes there. I think we can complete this row then, which must be 4 and 8. Yeah, and this cell can't be 8, so it's 4, that's 8. Those are 2 and 6, and this can't be 2, so it's 6, that's 2, which removes some stuff. Those digits have to be 5, 6, and 9, which doesn't tell us much, except that 9 can't go there. And I guess we can do the same here, or something. 1, 4, and 5, but 1 can't go there. Sure. We have other stuff to do maybe. Like 5, 6, and 9 here as well. We can remove 5 from here because it can't be there. So, and we can move 9 from here. Okay, I don't think there is much. And we can do like something similar here, I guess. 1, 5, and 4. 1, 4, 5. Where this can't be 5 because it's pointing at a 5 here. But that doesn't do much. That can't be 1. Okay, I think this is just another case of me being blind trying to spot stuff. Some Sudoku-esque thing. This is 1, 4, 1, 2, 4, and 5. So 2 is in one of those cells, but we already knew that, I think. Yeah. Same here where 2 is in one of those cells. One of those cells. Alright, then there isn't much there to look out for. Eight is in one of those cells. 2 is there. This is 5, 6, 8, 9, and then we have 4 as well in this box, which we don't have. Okay. I'm probably just missing Sudoku at this point, so let's quickly take a check as to where 2 is one of those, 8 is one of those cells. Yeah, no, this is just Sudoku. Oh, right. One of these cells are 5, which stares at that, so that is actually just 4. Which means that, well, 5 is one of those cells which sees that as well. So that's 6. Oh, and it also sees that cell, so that's 1. 5, 1 must therefore be here, 6 must therefore be there. Alright, that resolves everything. 5 means that this cell can't be 6, and it can't be 5 either, so that's 9. Meaning that's 5 pushing a 9 down there, that's 4. This can't be, well, this 6 sees that cell, so that's 9. That's therefore a 5. This is a 1, that is a 5. This 1 sees that cell, so that's 6, 8, 1. And I think this 9 sees that cell, so 4, 2, 9. And we're almost done here. Those digits are 6 and 4. Okay, thank you. That column would be 4, 6, and 8. So that can't be 6 or 8, so that's 4, 6, 8. And here we have 2, 4, and 6. That can't be 2 or 4, so that's 6, 4, 2. That digit will be 7. Not 7, sorry. 4. Those digits will be 5 and 2, which we can place. Those digits are 2 and 8. 5 and 8, which we can place. And that final digit would be a 6 to complete in 8 minutes and 51 seconds. Well, I hope you enjoyed that puzzle. I'll see you next time. Bye bye.